Good morning, everybody. So we are starting the book today, and this is a stem off of what we've been going over the past month on quadratics, and now this is all coming together. So without further ado, I'm going to give you guys three different examples, which will help carry you through the majority of the thinking on today's work, and then I'll see you in the Google Hangouts. It'll be pretty much click a link like you did for Zoom. It'll be super easy, so nothing too different there. So here we go. First example, let me make sure you guys can see all of this. It says maxing area. Okay, this is quadratic applications. So, my first example is 500 feet of fencing. You want to build a rectangular yard with the most area. What are the dimensions? You got 500 feet of fencing, and you want to build a rectangular yard with the most area. What are the dimensions? So I set up a couple notes here for you guys. We got our perimeter equals this. We know this is our standard equation. P equals 2L plus 2W. So replace the perimeter with 500 because that's what we're working with, is equal to 2L plus 2W. Now I want you guys to solve for L or solve for W, but just whatever letter you choose to solve for, always solve for that letter for this type of stuff. So in this case, I'm just solving for W. I'm solving for L, my apologies. Subtract 2L from both sides, then divide both sides by 2 in front of that L. You're left with an equation in terms of L equals 250 minus W. I also know the area formula of a rectangular is length times width. So now that I know I got both dimensions in terms of W, now I can solve this, and this is a quadratic function. So I know to do W times 250 minus W, and instead I just put the W squared first. So this is a negative W squared plus 250W. Now, this question says to find the maximum area. So we're not solving for X. We're essentially completing the square because we got to find the max, which means you're finding the vertex. So we are completing the square. So now that I know I have to get rid of this negative in front of the W, I divide the negative 1 out of both of these two terms, and so now this is negative 1 on the outside, W squared minus 250W. Half of this is 125 squared. 125 squared is 15,625. Now, remember, I do this times this. I brought in a negative 15,625, so I must take out a positive 15,625, okay? So now when I break this down further to get this in vertex form, I'm left with negative 1 parenthesis times W minus 125 squared plus 15,625. Your X is your input, always your input. There's your dimension. Your Y is your output, always your output. So this number relates to the total area. So the vertex form answers two questions in one. Tells me my dimensions, 125 by 125. I'm just got to put this out a little bit. 125 by 125, so this happens to be a square, which makes sense. Squares always produce the maximum area. And the area is 15,625. Now I'll get another example up in 1 second. All right, so here is my second example. Very similar to the last one, just different numbers and a different question slightly. So my question says, find the largest rectangular area you can enclose, which means go around, with 128 meters of fencing. So I wrote up some just the thinking through this, so feel free to pause this whenever you want just to jot this down and make sense of this, or go back and rewatch it. I know my perimeter is 128 meters, so I set that equal to my formula, 2L plus 2W, and like before, I want to solve for W. I want to solve in terms of L, so I just subtract 2W from both sides, divide by 2. My length dimension is represented by the equation negative W plus 64. I also know the area formula is length times width. So I now know my length in terms of W is negative W plus 64. So there's my length times my width. And when I do distributive property, I'm left with this as my formula for my area. Now, to go one step further, which is the whole tie-in to completing the square and knowing what maximum and minimum mean, we are again using completing the square to now find the vertex to then pick apart what question I'm looking for. So I divide out that -1 of both of these two terms, and I'm left with this. When I divide that out, I get w squared, -1 on the outside, minus 64w. Half of this 30 is 32, or -32, squared is 1024. Remember, I brought in a -1024. I must take out a positive 1024. So when I break it down into vertex form, I'm left with w minus 32 squared plus 1024. But my question asks specifically, find the largest rectangular area. Okay? Pay attention to this, because this is a type of question I put on this week's quiz to know if you're paying attention to what numbers actually mean. This is my dimension. This is my area. My input, my output, always. So there's that. I'll be back in just 1 second for one more example. And my last example will look like a question from your homework in the back, towards the end of the assignment today. So this one's kind of funky, so pay attention. This one says, fence a 3-sided area using just 100 meters of fencing. Find the dimensions to produce the area. So I just drew something here, like an imaginary, pretend you're enclosing a rectangular area that is up against, say, a river or a waterway. So there's no need to put a fence along this side because that's already blocked off from the waterway, obviously. So this is just doing this, and we know we got our width, and our length looks like this. Now, remember, we're adjusting our perimeter formula because we no longer have 2 lengths. We only have 2 widths. So given that, I want to solve for my length, which requires less work, obviously. Just subtract 2w from both sides. Your length is equivalent to 100 minus 2w. So like before, now that we know all of our dimensions in terms of w, we can go into our area formula, which is length times width, replace the length with this expression, 100 minus 2w, carry out the distributive property to both, and I put my w squared term in the very front. That's standard form. So that's -2w squared plus 100w. And then I'm going to, again, I'm trying to find the maximum area to produce, like find a fence using 100 meters, find the dimensions to produce, I should have said, produce the maximum area, my apologies. So we divide out the -2 of both of the a and the b term. I'm left with, on the inside of my parentheses, w squared minus 50w. Half of that is 25. 25 squared is 625. Now remember, I do this times this. I brought in a -1,250. So I must take out a positive 1,250. So then I break this down into this. So the question says, find the dimensions that produce this area. So your dimensions must be 25 meters. And if you want to go in and check your work, which I always urge you to do, go ahead, replace this with 25. Always check your work, make sure it works. And this is 25, so this is 100 minus 2 times 25. 100 minus 50. I'm left with 50. 25 plus 25 is 50, plus 50 is 100 meters. So there's that. I will for sure see you guys in Google Meets today, because there's going to be some questions on probably some of the wording, which I fully expect to see a lot of you today between 10:30 and 11:35. See you then.